So the rate of reaction, now it's the fourth factor that we're going to discuss here, is basically the rate of reaction also depend upon the physical state of the reactor. This will depend upon the physical state of reactor. Physical state of reactor. Okay, what does mean with the physical state of matter? Let's consider we have three states of matter. First is gas. No, first is solid, but we are writing. I'm writing in a descending order. You can write it in a ascending order. Liquid, LIQ I'm writing only, and solid. You know that these are the three states of matter that you need to keep in mind. Plasma is also a state of matter, but we are not discussing it here. So, ionized form a state of matter, right? So, if we talk about gas, you can see the molecules are far apart from each other, something like this, and then they have a large void spaces in between them. If we talk about liquid, they are intermediate spaces, but spaces do exist in it, right? But if we talk about solid, they are tightly packed. We cannot counter any sort of space between their atoms. So basically, I want to say that the rate of reaction in solid is slow just because they have no space in it. Due to it takes a time to get to perform reaction. As for example, take this example of this brick and put it in the sunlight. It takes a time to perform reaction. Sublimation cannot anything. If I take an example of this cold drink, then you add something into it. For example, any sort of thing, it takes time to get dissolved into it. But if we talk about the example of this gas, it performs reaction. For example, now you have put the any sort of utensil just above it, and you're cooking something. So it performs a very instant of reaction if the rate is fast, right? So rate of reaction is directly proportional to the physical state of reaction. Now talking about the fourth factor that we're going to discuss here, intensity of light. Rate of reaction also depends upon the intensity of light. Okay, let's take an example of photons. Sunlight. Okay, let's take sunlight. So the rate of reaction also directly proportional to the intensity of light. ROR is directly proportional to the intensity of light. Intensity of light. The higher the intensity of a light, the more the photon, the more the rate of reaction. Intensity. It is also known as zero reaction, which means they are not derivable consideration of the reactant. That will be discussed in the later on videos. But intensity, as you can see, there higher the photons, higher the level of sunlight, higher the HV, which means photon, higher photon, high reaction, ROR will be higher as well. So this is also this is dependent upon the rate of reaction. The rate of reaction also depends upon the photon. If we talk about the next factor here, which is temperature. This is a main factor that we'll be discussing in detail as well. Temperature. Temperature matters the most. For example, the rate of reaction is directly proportional to temperature, but it varies with temperature, right? Rate of reaction is directly proportional to temperature. At 0 Celsius, increasing the temperature 10 Celsius, which means increasing 10 Celsius, increasing 10 Celsius, rate of reaction increase 2 to 3 times. Therefore, this is the particular term is given for it. But now I'm not discussing it. I'll be discussing it when I detail in a detail. I'll discuss this the factor temperature. That the rate of reaction. The rate of reaction. Rate of reaction increase 2 to 3 times. 2 to 3 times it increase 2 to 3 times. Rate of reaction increases 2 to 3 times. So they need to just bear in your you need to bear this in your mind.